Hello everyone, welcome back to the Database Management System Unit 1 Session 3. So in this session we are going to start up with the Session 2's recap, and along with that we are going to discuss the various advantages of using database management approach, and we'll also discuss some of the differences between the file and database approach. So to start with the recap of the previous session, that is session 2, we had discussed the different users. Hope you have remembered them. Which are the two important users, database users? The first one is actor on the scene and the second one is workers behind the scene. So both are important as we have discussed last time. Let us just summarize it once again. Who are actors on the scene? There are four important people here. Database administrator, we also call him as what? DBA. He is very important person, very responsible person to control the overall database. Then comes the database designer, who is responsible for database designing and understanding the requirements. Then end users are very important. As I have told you, there are how many categories of end users? 4 categories. So which are those 4 categories? Hope you remember. Naive or parametric end users, casual end users, standalone end users, and one more is, yes, sophisticated end users. See, as I am recalling, you are supposed to remember what, or you have to go on answering. It's like a questionnaire, okay? So along with that, there are 2 more important people, actors on the scene. Who are they? System analyst and application programmers. Hope you remember. System analyst is who is the system analyst? The one who will get the user requirements, okay, who will understand the user requirements, and those requirements will be converted to programs. By whom? Application programmers. Do you remember the term which I have related to application programmer? That is software engineer. Yes. Then after that we had discussed workers behind the scene. Workers behind the scene are also important people who work behind the scene. So who are they? Who will be working in the back end? Who are they? Database system designer and implementers, who are responsible for designing the overall database management system, okay, and also those are the people who will implement different operations. Then hope you remember tool developers. We had discussed tools are what? Tools are optional packages which we are using for improvement in performance. So the people who develop them for DBMS are tool developers, and the other last important people who work behind the scene are operators and maintenance personnel. I had told you these are very important people, because in order to maintain the overall database we need the operators and maintenance staff also, so that the database should be in good condition and there shouldn't be any problem. So for that the maintenance personnel will be continuously working, right? Okay. Coming back to today's session, we have the advantages of using database approach. See, there are 9 advantages as you can see on the screen. We have summarized them in one shot. It's very important for us to understand and note down all these 9 important aspects, because from the examination point of view also it's an important question. You may get this as discuss the advantages related to the database approach. So then you have to explain all the 9 points, right? So which are those? So each one we are going to discuss in detail, okay? So coming to the first one, which is the first one, controlling the redundancy. So when I take this term redundancy, all the time what you need to remember is something repeated, something duplicate. Redundant means what? Repeated stuff. So here I am talking with respect to database. So redundancy in storing the same data multiple times will lead to what? Problems, right? See, you are storing the same data n number of times. That will obviously lead a lot of problems, okay? So first and problem. What will happen when I store the same data multiple number of times? Then space will be wasted, memory will be wasted, storage space is wasted. Okay, and then what will happen? Files that represent the same data will become inconsistent. Inconsistent means what? Invalid data. See, what I can say here is like you can imagine your file, your record, or whatever the data of yours, like your name, your register number, is stored by different departments like office, in your own branch, and in the higher authority where we send your details to higher authority also. So all these three should have the same data. So what I should do, instead of saving 3 copies, I should make sure your file is only one, that is stored in a centralized database, and all the 3 people like office people, department people, and the higher authority should access that data. Because if I update your information, like suppose you have changed your address or mobile number, only one file I will update, and all the people who will access can see the updated data. Otherwise, if I maintain the 3 files and 3 people will see, only in office file it is updated but not in the department and higher authority file, then those two will see your old data. So that will become what? Inconsistent data. So saving 3 copies is wasted of space, that is a storage space, and storing multiple data will lead to so many problems. And what will become, if you update your data, it will become an inconsistent. Inconsistent is nothing but data which is updated in one place and not updated in another place. So in order to make sure it should be consistent, there will be only one copy which is supposed to be shared, and that is what we are going to follow in our database approach. So what we do here what we do is, we will keep a single repository of database that will be maintaining defined once, that is all the data is defined only once, and then it is accessed by n number of users. Okay, so that is how we are controlling the redundancy. Hope you understood this. It's a very important point, because many places we are going to get this term redundancy. So remember, redundancy is nothing but repetition, duplicate data. So that is what we are controlling using database management system. Next point is restricting the unauthorized access. What is unauthorized access? Some of the data is very confidential. I don't want to share it with across the many users. So when I am especially maintaining a huge database, see that when multiple users share the large database, then most of the users will not be authorized to access all the information. See, for example, I have a file which is having password, and I don't want everyone to see the password, right? So I will give the access only to the authorized person. If he comes and gives his ID to me, I will allocate the password, being an administrator. Okay, so that is what I am going to do. But I will not be showing all the password to all the users, because only relevant information I have to give only to the authorized people. So that is what we mean by authorized access of the information. Who will do this? DBMS will ensure that it will provide you essential security and authorization, so that you will access your relevant data, not other person's data. So here we have the DBA, that is, who is DBA? Database administrator. He will create the different accounts. Suppose if I take the example of college again, so student will have an account and accessible to some of the data, and then lecturer will have an account where he will be accessible to some higher order data, okay, some of the confidential data also. And if I take the admin, the overall admin, principal, who may access even the lecturer data along with the student data. So the highest authority, as is a DBA, can access all the data, and they can create an account to specify the restrictions, like only specific amount of data will be accessed by student, then some additional data will be accessed by lecturer, and overall entire data can be accessed by administrator. Hope you have understood. So DBMS will allows us for restricting the unauthorized access by providing the security and authorization. So now if you come across with something called as very good advantage, it is providing persistent storage for program objects. See, I am having a data which is related to real world. This is something like a movie data. Movie data I cannot just categorize into numeric or character. I have to take enormous of data. That's a video data, video file it is going to be, and I am taking it as an object data here. Okay, so object oriented data I am going to take, and I will consider it for the persistent storage. Persistent storage means what? When I am transferring this data from one device to another device, or from one software to another software, it should be continuing working fine without having any effect on that. Okay, so it means it is a data which is not going to change, its operation, because just because I'm transferring from one to another device. Okay, so such data we can call it as like a we have to understand it. That's what we are mean by this persistent storage of the program object. So that is what it is very, very important to maintain, that when it comes to object oriented database typically offer data structure compatibility with one or more object oriented programming languages. So when I transfer it from one device to another, there shouldn't be any problem with it. So that is what we call persistent. Persistent means what? Which is continuous, which should not be affected by any other stuff. So it will continue working in a determined fashion. Okay, so that is what we mean by persistent data. Then providing the storage structures and search techniques for efficient query processing. This is one of the beautiful option. That's the advantage what we get with the database management system. So what we do here is the database systems must provide the capabilities for efficient execution of queries and updates. See, what is that efficiency means? See, if I go to Google and I want to search some information, I'll type the question like, search this particular data for me, definition for DBMS. And imagine when you type definition for DBMS and press enter key and wait, Google will take 10 minutes. Are you able to wait for 10 minutes? Do you have a patience for 10 minutes? No, nobody will have, because it's not efficient searching. Obviously, nobody will waste their 10 minutes just to search the database definition. What I do, I'll close that and go to some other search engine, isn't it? At the same way, like the same scenario will apply to database management system also. If I am searching for some information by using this query processing, it should answer me back. That is, it should get the result. It should access the data to me in a very fast manner. That is, it should be speedy. Okay, so efficient execution of queries and updates should be very fast enough. It should be very speedy enough. So then only I will be adhering to that particular system. So DBMS must provide specialized data structures and search techniques to speed up disk search for the desired records, isn't it? So it should have specialized techniques and data structures so that it should be very, very fast enough. Once I type the query, within a fraction of second, maybe 5 to 6 seconds, I should get the answer back. So then only I will prefer to work with such database management system. So that's what I mean to say, indexes are used for this purpose. What is index? I'll give you a very simple example. You have a textbook, and in that I will ask you to search for some information. How do you search? First you will check the main headings, then you check the subheading, and then you see the page number. You get the information, you am getting some definition, you get that page number, directly open that page and show me this is what the information you have asked. But if I remove the page numbers for you and ask you to search the information, it is very, very difficult for you, isn't it? What you do? Every page you should go on looking for the information sequentially, one after the other. So that is what I mean. Index means something like your page number. So that page number will speed up the operation, isn't it? So once I have a page number attached to every page, I can quickly, directly access that information. So such indexes are used for what? Efficient query processing. And also the query processing and optimization module will be there in your database system, that is DBMS itself, which will enhances all these operations, that is query processing and all, that will be enhanced using this query processing and optimization module. So what it is, how it works, it will be explained in the future sessions. So while explaining the architecture of overall database management system, you'll understand and get more information about this. For now, what you have to understand is DBMS will provide us a very beautiful and good data structures and search techniques to get the efficient query processing. So next, very important feature again, that is providing backup and recovery. Backup and recovery is very important. Because why it is needed? You will not get it easily, because I working as I have explained previous classes also, I losing one or two files may not make much difference. You losing one or two files from your folder, okay, I'll type it again, what's the big issue? No, it's not the same with respect to a huge database. Imagine something related to bank. So there, if they lose their database, it's very difficult for them to track. So what they have to do, they need some security. That is what we have, that backup and recovery. If any hardware or software failures will happen, all the data should be recovered back. So backup and recovery subsystem of the DBMS is responsible for what? It is responsible for recovery. Okay. So the best example what I can quote you is, if you are working in a computer system and fails in the middle of some complex updation. So that is what I have quoted here. So you just imagine, to be particular, I'll quote it for an ATM transaction example. You are trying to take the amount from your account. You type your PIN number, you choose the amount, like you imagine you have some 2000 rupees in your account, and you are trying to withdraw 1000 rupees, and as soon as you press enter OK, then suddenly system crashes and you will not get your amount due to the system crash. What you do? You will be panic, because immediately you will get a message, your account is debited 1000 rupees and your balance will become, instead of 2000, now it is 1000 rupees. You will get panic, you will get scared, what happened? So immediately what you do, you will go to manager, you will report him. So what is the job of the manager now? Immediately he'll recover back your amount by using what? Backup and recovery option. He will check out the transaction was not success, it was failure and the system crashed. So the amount in your account should not be deducted, it should be given back by, again, your account will be reflected as 2000 rupees. So this is what backup and recovery. It is very critical and a very essential feature of database management system. Hope you understood this. Next, providing multiple user interfaces. So this is again an important feature, because we have different users. Hope you remember which are the different users we have having. End users, you remember? Who are they? There are casual users who want to browse casually. So if I ask you to browse using commands, you have to open Google using a command. Will you do? No, I don't want. How I browse? I want a browser. In that I'll go to the typing option. There I'll just type Google. So it should get me to Google. So for a casual user, I may have some forms, okay, and at the same time I may have some different user interfaces for bank people, because bank people will not every time open a form and check for the graphical user interfaces and all that. What they do, what they need is, they have 100 transactions in 1 hour, or from morning to evening there are some 1000 transactions, all at a time they want to execute. For that they don't want to click every form again and again, they don't want to type the command. So what they want to do, for a overall transaction they want to use only one key, one particular command code. That is what they want, because they want their operations to be executed in a simpler way, in a easier manner. So I can categorize them. Bank people can be categorized in which type of users? Naive or parametric users who are continuously querying the database. So command codes can be used for parametric. These are the examples. So every different user can be having a different interface. So we can provide what? Multiple user interfaces in DBMS. And the next advantage is, I can represent a complex relationship among the data. So what it is, I can take my data as the related data here. So DBMS must represent a variety of complex relationship among the data. So what is that? See, I am updating my data, and that data should again be related, and everywhere it should be represented. It may be however distributed in the thousands of users, hundreds of users, it should be reflected, and that update is related to the data easily and efficiently. So for example, I have the three entities. Just now I have given you student example. Student is related to office, student is related to his branch, and student is related to the higher authority where his data is shared. Suppose I am adding a new entity to this student, that is, he has to fill the feedback form at the end of each semester. Then what the student is supposed to do? Student is again related, all the students are related to that feedback form. They have to type in their opinions about various subjects, topics, lecturers, and that complex relationship will be immediately managed and updated to every other form. Okay, all the others should be able to access that feedback also. It is not that again I have to relate individual student, again I go on creating individually. No. So this is what a variety of complex relationship among the data can be easily maintained. That's one more important feature of our DBMS. Again, when it comes to advantages, we have to focus on what? Enforcing integrity constraints. Integrity constraints is a very good, beautiful feature available for checking the validity of the data. So if you have a data and it is not valid, it is not a data. It will become a garbage, isn't it? If I say semester, so semester means what? Somebody will come and enter -2. Can be a valid value? No, -2 cannot be a semester. Somebody enters 0. Is it valid for diploma? No. Somebody enters 8. Someone enters 7. No, all these are invalid. Then what is the valid value? Semester for diploma is only going to be 1 to 6. That is 1, 2, 3, 4, 5, 6. No other value, no other numeric it should accept. So this is what I mean by a constraint. I can enforce that. Okay, once I define, it is applicable for all the students in the database irrespective of their branch. The semester remains same for the mechanical branch also, civil branch, computer science branch, any other branch you take, it remains same. The same integrity constraints hold good. So that's what I can quote it as. See, most database applications have certain integrity constraints that must hold for the data. So integrity constraint is nothing but what? A condition, a validity I am applying for my data. So the database management system, the DBMS, should provide the capabilities for defining and enforcing these constraints. It has to be taken care by whom? DBMS. And the simplest form of defining integrity constraint is just defining a data type for each data type. Okay, that is, for each and every data item I am going to specify the data type. So for example, name should be always characters. Semester should be always what? Numeric. It cannot have a value apart from 1, 2, 3, 4, 5, 6, as I have just told you. So these things need to be enforced by whom? DBMS. That is, DBMS has to enforce the integrity constraint. Why we are using them? Because for the good data, valid data, correct data, we have to enforce the integrity constraints. Okay, and then we have permitting the inference and actions. So this is some advanced features. You can call it as the database management system, related database management system. We also term it as RDBMS. Extension of this can be something like a deductive database. What is deductive database? I already have my database, and using that stored database, I will deduct a new information from the stored database. Such systems are called what? Database, that is deductive database system. So I am defining the new rules, I am defining the new things by using the stored information. Okay, so this is an advanced feature, but for the time being, you will understand that from the stored database, we are deducting the new information that is known as what? Deductive database. Example, what I can quote here is like I already have a database. I have enforced the integrity constraint, like I have already told you student name, semester and all that. See, somebody entering the data should always taken care that he will enter the valid data. So if someone is adding a record, updating a record, suddenly that update will trigger an action, that is a stored procedure will be called, we can call it as what? Trigger. Trigger is nothing but what? Is a form of rule activated by updates. This can be example for our inference and actions. The same way we can also use a stored procedure to enforce some rules for the database. So like this we can we can permit and inference some rules and actions. Okay, so those are the 9 important advantages of database approach. Apart from that, we can also have some additional additional benefits also. What I can say here is we have some additional implications. Those also can be, I'll just brief out. So what are the additional benefits we are getting? That is, we are enforcing the standards. Yes. See, as I told you, once I define a proper semester, I am enforcing a standard to the entire organization. Everyone should enter the semester in the same format. Same way for name also I can define. For any other data type also I can enforce the standard. Proper structures, formats, all the thing can be used by defining only once in the database. If I do all such things, obviously it will reduce the application development time. Yes, because application development time is obviously reduced here because we are using the one data, that is centralized defined data, will be used by multiple users, many users. So it will reduce the application time because I don't have to create my own database every time. So I can share the database which is already available for us. And then, is it flexible? Yes, database management system is very flexible. As I have told you, you can change the program, you can change the data, but both are separate. So changing our program will not affect our data and changing our data will not affect our programs. So flexibility we get here. And also I told you, once we update information in anywhere, because it is a centralized one, so the same information is stored by 1000 users. Then is it updated everywhere? Yes. So availability of up-to-date information at a single point of time. You don't have to update 1000 records. You have to update at one time and all the 1000 users accessing the data will be up to date. They will be accessing the up-to-date information. Okay. So coming to the end of the session, we have some differences between file and database approach. We are discussing only related to database approach so far, benefits, characteristic, advantages, all that we have come across. You already know what is a file means, isn't it? You have worked with programming languages, you know what is a file means. Now let us compare the file along with the database approach. A file is what? File is each user defines and implements the file. Every time single user maintaining his own files. Okay. What about the database? Now compare with that of the database. Database approach is a single repository. It's not every user maintaining one database. What? Only once I am defining the database and all others will be sharing that database. So database is defined once, single, that is it's a single repository maintaining the data and all others can access that data. Whereas file is what? It is every user has to define and implement his own file. So that is the first difference. Next comes to redundancy. So what is redundancy? Duplication. In case of file, yes, duplication may happen because the same file can be saved as multiple number of times having the same information. File 1, file 2, file 3, up to file n number of files can have the same information. Whereas data, In case of database, what we are doing? We are controlling the redundancy, no duplication. We are avoiding the repetition of the data. Okay. Next comes to data dependence. In case of file, what? The file is completely dependent on the data. So if you change the data structure, you have to change the related application program. But in case of the database, it is what? Program data independence. A very beautiful feature and an important one. I have told you already. If I change data, no need of worrying changing of the program. If I change program, no need of worrying of changing of data. So program and data are treated as the separate ones, and changing will not be, affecting, one change will not affect the other. So program and data are independent here, whereas in case of file, they are dependent. And what about the flexibility? File, that is in case of file approach, provides the data in flexibility. We will not get the flexibility when we have or the same flexibility what we are getting with respect to what? Database. So as I told you, across the devices, across the number of users, the same data can be passed across the different software and hardware. It may not change its structure, whereas in case of file, it may not be possible. The different formats will affect the file structure also. And then incompatible file format, that's what I am telling. So we have different file format that may not be compatible with every other software and the availability of hardware and all that. Whereas in case of database, they are having what? Compatibility in their formats. And the last one is when it comes to security. Which is more secure? Database, right? Because database provides what? Which is that feature just now we have discussed? Backup and recovery. Is it possible with respect to files? No. So when it comes to security, what we can have is the security for data is low, whereas in case of database, it is high. Why it is high? So I have given the example. It is because of backup and recovery. So with this, we'll end this session. But wait, we have some questionnaires for you, some multiple choice questions, which we can relate our discussion just now what we have discussed. Okay, go on. Reducing duplication of data effectively reduces what? Amount of time, amount of storage, complexity. Which is the correct answer? All the above, right? So all the above. If I reduce the duplicate data, that is redundancy, it will enhance what? It will save my time, it will save my storage, and also it will reduce the complexity, isn't it? Okay. Next, the multiple storing the same data. That is, if I store the same data multiple number of times, which is the term? Concurrency, duplicate, all the above. Which is the answer? Answer is redundancy, right? Because see here, duplicate, you may get confused. Even duplicate can be answered. No, but you use the appropriate term related to DBMS. What is that? Redundancy. Redundancy means multiple storage of the same data. Next question. Centralized control of the data by DBA doesn't reduces the redundancy. Is it true or false? Does the centralized control of data will not reduce the redundancy? False, right? It is. Answer is false. Okay. Then fourth one, dash ensures the updating to the database is done one by one at a time. So this is what we have come across with this feature, concurrency, isn't it? Concurrency means what? Simultaneous transactions. Okay, if the simultaneous transaction happens, then also it should be done as if one by one. Redundancy means what? Repetition, duplicate. Okay, so redundancy is not the answer, neither the duplicate is the answer, all the above is not the answer. What is the answer? B, concurrency. Then database can be shared by any number of application programs. True? Yes, it is A, true. Data integrity means the data in the database is what? Integrity constraint, enforcing the integrity constraint. What it should be? Accurate and consistent. Backup and recovery, redundant, none of the above. Backup and recovery is related to something recovering the data. Okay. And redundancy is related to duplicate of data. So our answer is what? Accurate and consistent. Answer is A. Then in case of file based approach, data security is just now the last slide. What is the data security for file approach? High, low, medium, none. It is low. Correct. B is the answer. And program data independence is the characteristic of file based approach, database approach, both A and B, none of the above. What? Answer is database approach, because database approach only will give us the program data independence, whereas file based we have it is data dependence. Okay, so the answer is B. Okay, here are the answers. So thank you all, thank you for your kind attention. Any queries, any questions, you can feel free to contact us. Okay, thank you team for your continuous support and encouragement. Thank you all.